Okay, here's the AP calculus free response question. It said fish enter a lake at a rate of the model by the function e given by the et equal to 20 plus 15 sine the 6 pi t over 6. And the fish leave the lake at the rate of model by the function L, that's both et and lt measured in the fish per hour, and the t measured in hours since midnight, t equal to 0. The question asks how many fish enter the lake over the 5 hours period from the midnight t equal to 0 to the 5 a.m. t equal to 5. And actually, we can use the integral of the et. I think that e means for enter, so this is the enter lake for 5 hours. So we can just write the integral of the et from 0 to 5, So we can just write and so dt. So we can use our calculator. Okay, let's open our calculator and put our function into the EF1x. EF1x, let's put the 20 plus 15 sine of the pi, because the variation in here is x, so we put the x in, and the 6. So here is our function. Then we see the plot. We can see this function is like this. And if we want to find the integral, we can just use the function of the signed area. Then we says go to from 0, okay, to, and go to 5, okay. So this is a signed area. So from 0 to 5 is 153. So I can take is 153. The number is 153 here. And another way to do it, we can use the CAS, our calculator, and also put our function in. If you are not familiar to use that the graph function, but you want to use the typically way of the calculator, you can put this into here too. And the sine of the shift pi, and also the x, and this over 6 d of the x, and we enter in and find this, and we have this kind of rounding, and we can use the shift setting to see the radius and see the rounded. So the rounded is okay. Then we go back to the CAS and copy and paste. We can have another type of the answer, and we ate this one. We got a 153.45 thing again. So just like the plot where we use a 0 to 5, we got the same answer. Actually, we got the same answer as the previous graph one. So this is how we use the CAS one, how we use the CAS one to find the 2. So since then, we can put the number of 153, so nearly 153 to here. It didn't tell us we need to write a unit. So this we put the unit, that will be fish. And how many fish? 153 fish during this time period. Yeah, you can write the answer like this. Let's finish the question B. So what is the average number of the fish of the lake per hour, 5 hour period of the midnight? So that's what we need to integral of the lever of AT. So let's find the integral of lever of AT. 0 to 5, the LT of dt, and this is the total number of the leaving. That's every hour we multiply with 1 over 5. So we find so divided by 5 means that we got the every hour. So that we equal to, then we needed to use our calculator again. Okay, so the next part we need to put our function for our living. So we just put 4 plus of the 2. Then we use the power of 0.1. So we change it to x2. So we change the x power of the square. That's the power of square. 0.1 like this. Then we enter in. So we don't need the first one. So we just 11 is a click. Now we just need the second one. We go to plot function and assign the area. Let's steal from the 0 to 5. Okay, go to 5. Okay, then we get okay. So this sign error is 30.29 watt. So 30.295188. So we just take 30.295. Okay, 30.295. So we go back to our cast. 30.295. I forgot. No, let's go to the function again. The sign area. Go to from the 0 and go to from and to 5. Okay, 30.295. Okay, 295, no problem. And that's divided by 5. We got 6.059. So it didn't tell us to go to the whole number, right? So we can just use this conclusion. And also we can use another way. So the traditional way to do it, we can use the 1/5 and put our integral thing into here, 0 to 5, and our function is 4 plus 2 power of 0.1. So we change the t into x2 and the power and square and d of x. Enter this thing. Yeah, syntax error. I think the syntax error should be here. Because I didn't put a multiplying here. Yeah, so you don't need to use this thing to do this. You can just use your finger to do like this. So it will save you a lot of time. Node alpha. I think I just use this one. Okay, so we got this. You can see the 0.59070377. So we got the same answer like the previous one. So we got so we keep to the thousands. So we keep to the thousands at 6.5059. Okay, I can put into the number is 6.059 fish. Yeah, it's a fish. Yeah, fish per hour. So this much of fish per hour. So you can write the answer, the average number. The fish leave the lake of the over 5 hour periods is 6.059 fish per hour. Yeah, you can write like this. The question C. The question C says we need to find the greatest number of fish in the lake from the t from 0 to the AM8 from the real meaning the time t. So here we got the enter in, we got the leave out, so we can find the total t. The total t will be the total t. Let me change the color into our purple one. The total t can write as the ET minus LT. The ET minus LT. So it's a rate of change of the total number. So because this is also the rate of change, so we can use the graph calculator to find the stationary point or the critical point. When we find the critical point is in the 0 to 8. That's a place that we can find the relative minimum or relative maximum. Let's put it into our graph calculator. Okay, let's go back to our function. Because we already have the f1 and f2, so the f3 we will definitely make it as a tt. The tt just as I write, so we can write this thing as the tt because it's et minus lt. The first one is the et, the second one will be the lt, so the third one I can just write it as a function 1, function 1 of the x minus the function 2 of the x, So we can just find our third function is the tt of this one. So the tx, change it into. So we have plot. We got this one. We got this kind of the function, and we can use our menu to find our critical point by find the roots. So let's just put it in here. Cancel function. I think I just this is the root, and plus a plus in here. We can find the root is 6.2 2035 blah blah blah, and this all thing. So this root we can find this root is also in the inner of the 0 to 8. So this stationary point, and because this is a critical point here, we can see the slope from left is a positive, slope from the right is a negative. So this definitely this is a relative maximum. So yeah, I lost it, so I need to put the slope again. Cancel function, no slope, the root again, yeah. So 0.203. So this when t equal to 0.203, that will be the maximum point for the original maximum. Yeah, because this is a critical point of the function et. Come back from the graphing calculator, so that means our tt equal to 0. And from our calculator, we can find the critical point as a t equal to 6.203, 6.20, so 0.035. So we keep it as 204. Yeah. So that means the time is a 6.204 hour. It gets the greatest number of the fish. Yeah, so AM. So you need to write the answer for this question too. Okay, let's finish the last question. The last question D said is the rate of change of number of fish. Because this one you need to highlight it out. It doesn't ask our rate of change in fish. It says the rate of change in the number of fish in the lake increasing or decreasing. It's a rate of change in the number of fish. Because the rate of change in the number of fish is not the rate of change of the entering or the entering the fish per hour. This is the rate of change of the number of fish that in lake increasing or decreasing at 5 a.m. So this one need to be the rate change of the fish per hour. So in here we need to write it like this one. We need to write like the enter of the differentiate of the enter t minus the differentiation of the leaving t. This is our new function. Our new function of the rate of change of the lake increasing or decreasing at any time of the t. So there's a 5. This is at 5. So we can write this as a e prime of the 5 minus the L differentiate of the 5, like this one. So we can use our calculator again. Okay, so this is a final question. This is question D, and for the question D, because we know that should be rate of change in number of fish. So this the fish per hour, yes, per hour square thing. So we need to find the differentiation of the ET minus the differentiation of the LT. So this is the ET, this is the LT. So we can just write here as the differentiation of the f1x dx minus the differentiation of the f2 of x d of x. Okay, so we can have the f4. Then we see the plot of f4, then we go to 5. So we go to 5, and we can see the x equal to 5, the fx equal to negative 10.722 thing. This means that the rate of change was decreasing. The rate of change of decreasing. So this thing is like a second differentiation. The second differentiation. The differentiation of differentiation, right? So this thing we can see. Okay, so this thing will all concave down. That's a rate of change number of fish will decreasing because of this. So let's let's put our number, let's again put our number at 4x equal to -10 into our question. According to the graph calculator, we can enter it in is equal to -10.723. So this one is smaller than 0. So that means that the rate of change in number of fish in the lake is decreasing. It should be like this one. So this is all thing concave down. Yeah, it's all thing concave down. Okay, done. So this is all of the first question of our 2019 AP Calculus BC free response question, the first one. And I wish you enjoy this question answering, and I will record other video next time.